Finally, we need to study also the end-of-life management with new regulations, European regulation about the 95% of recyclability of the car, and we need to have this, the management of the end-of-life very simple and ecological recycling. Just a few words about the fibers. We have two kind of process, SMC and RTM. For those two processes, we need different kind of fibers. For the RTM process, it's possible to use unidirectional or two-directional fibers, which can give us a very important, very high level of mechanical properties. For the SMC, we need to use short fibers or non-woven long fibers whose properties are quite lower. That is the reason why if we use URTM process, we'll have a price which is quite expensive. And if we use the SMC process, we'll have a very low-cost process. So we focus on two fibers, flax fibers and hemp fibers. For the resin, we investigate three kinds of resin. The first one is a thermoplastic resin. As we need a very high mechanical properties, we focus on polyamide. Polyamide, which is a thermoplastic with quite good mechanical properties. The second family is biothermosets on the markets, mainly bioepoxy, epoxy partially biosourced. And finally, new bioresin, 100% bio, with furanic resin first, and then mimosatanium-based resin. For polyamide, we face a very important issue for polyamide is the fusion temperature for mixing the resin with the vegetal fibers. Today, if you want a very high mechanical properties of our composite, we need to have polyamide 6 or 6,6. And those polyamides have a fusion temperature, fusion point at about more than 200 degrees. So the vegetal fibers can't afford such a temperature. That is the reason why today we have some difficulties to have a good impregnation of the composite, of the fibers by the polyamide. When we try lower properties polyamide as polyamide 12, which fusion temperatures is close to 150 and 70, we have a problem of stability of the mechanical properties with high temperature. So today we stopped the work on polyamide, trying to find another resin. The other resin is a bioepoxy. This resin is very close to the existing resin epoxy. Very easy to use. We have no troubles to make the samples, and the first results are very good in terms of mechanical performance. So it's for us solutions, but quite easier solutions. It remains two or three main issues for this bioepoxy. The first one is the cost. Epoxy have a quite long cycle of productions, and the cost of the epoxy is also quite high. The second one is the end-of-life management, because even if it's biosourced, we don't know exactly today how to manage the end-of-life of the epoxy. So for us today, with those resin, we know that it's possible to reach our mechanical target, but we need to work on those two issues. Those new resin, for us, it's very amazing resin because we don't know a lot about those resin. So we started to investigate those resin and try to make some impregnation. The furanic resin first is made with furan, dioxide of silicium, ammonia, and acid. We have achieved a young modulus quite good, 6 to 8, far from what we want, but it's first result not so bad. Another very important issue is that for the cost is low cost resin, and also it's possible to have a high rate of production because we can produce parts with technology of thermocompressions in few seconds. So that means that this resin with flax fibers could be a solution for a car industry. One remaining issue is really the mechanical property. We have today 6 to 8. We need at least 15. So we have some work to do also. The other resin is mimosa tannin. It's an extract from wood. We are really at the early beginning for this resin. For the moment, we are trying to imagine the protocol for the impregnation of the fibers with this resin. This resin is made with tannin, hexamine, soda, and water. The problem of this resin is really the content of water. We have about 400% of water in the resin, which causes a lot of problem for the productions and for the process. We try, if we remove the water in the resin, we have too high viscosity and difficulties for the impregnation. If we have too low rate of water, we will have some problems for the polymerizations. But this resin look like is very close to the furanic resin, and we think that even if today we have not the solutions, it could be an interesting resin in matter of shock resistance. Because when we compare the two samples we had in furanic resin and mimosa tannin resin, the furanic resin is very fragile, but the mimosa tannin is more ductile. So a mix of those two resins could be a very good resin for our applications. Conclusion, we can say today that bioepoxy could be a solution for us, but just for single parts which are very high loaded. But we have two problems: problem of recyclability and half-life, and problem of cost reductions. We are working a lot today on those two bioresins, tannin and mimosa. We focus on that two resins because they seem to be in the target in matter of cost and rate of production. And we have a lot of work to do about the mechanical properties of those two resins. Conclusion says that ECOSHELL project remain an open project. Partners are ready to share the results we have. Today we are at the early beginning of the project because we begin this project in January, and every suggestion and other resins are welcome too. Thank you for that.
Thank you very much. Questions? Yes, Marek?
Several years ago, there was a Biocompack published a very paper regarding the life cycle assessment of the potential biopolymers and among them for the car production application. And one of the goals of that paper, if I'm not mistaken, is like that when we use that kind of polymers for the construction of the body of the car, so to get the same mechanical resistance, the weight of the polymer versus the classical metal must be much higher. So it means that consumption of petrol will be much higher because you have just carry not only the body of the car and passengers, question is, have you considered in all of your data the consumption of the fuel after application of the technology?
As for our projects, weight is a very important issue. Before beginning this project, we make some studies about the use of different kind of materials. We make models of body in white, and we place for each models different materials: steel, aluminium, and a material, plastic, because of the value of the young modulus and of the strength resistance. And we make some experimentation on it. And we find that on a lot of cases, we can earn about 20% of the weight with a plastic composite, which density is lower than 1.3. So with a composite, which density is lower than 1.3, it's possible to achieve our targets. That is the reason why 1.3 is one of our objective in materials. Yes, that is a level.
Okay, I have one question. You said about this tannin, I think
Tannin resin.
100% bio. What does it mean?
Not
Based on
exactly.
bio or what?
Yes, not exactly. Tannin is 100%, yes, but hexamine is not bio. But when we take all the resin, we are close to 90-70%.
Yeah?
Yes, that's 3% of.
You claim the 100% bio.
Yeah.
What does it mean? It's based on bioethanol or bio-producible
Yes.
ingredients or what?
Let's imagine 100% as a target, but it's very difficult to reach 100% effectively.
One more question? No more questions. Thank you once more.